This demo shows one of the tests from Spirent's Security Automation Test Pack, which is based on the 3GPP SCAS testing methodologies. The test emulates a user plane replay attack, where an attacker intercepts a message and later retransmits the message to the original destination. The attacker doesn't have to be able to read the message in order to replay it, and this type of attack is done to gain access to resources by replaying authentication messages or to confuse the destination host in a denial of service attack. The test demonstrates how you can use Spirent Security Automation tests to verify the UPF SUT drops any replayed packets. The test implements the 3GPP test case TCUP data replay UPF. An emulated RAN connects to the customer's 5G core. A secure data connection is established between the RAN and the UPF SUT, and the emulated RAN will duplicate packets. Some packets are replayed immediately, and some are replayed after a delay. The UPF is expected to ignore these replayed packets. Our security automation solution combines three Spirent products. Velocity, which is responsible for orchestration. It manages the test topologies and the resources. iTest provides the automation framework. It controls test execution, including repeated test iterations for goal-seeking tests, and it performs the result analysis to determine the pass or fail. And Landslide, which is the execution platform and is connected to the SUT and the home of the automation test pack libraries. I'm going to run the security test from the GUI. This screen shows the automation assets. There's a repository listed on the left-hand side. The user plane replay attack is in the vulnerability attack folder. We've got 3 tests here. These are individual test items. They're managed and run by the security automation solution. Each test can be run manually from this GUI or through an external API. If I select my replay attack test, and then to run it, I assign a topology which defines the resources needed to run the test, and then select a parameter file to run with the test. The user has the option to customize these parameters if they wish, and then we will click Run. The test has been queued. You can see it's showing as queued here. If I look under my reports, executions, I can see my queued test here is in progress. So what I'm going to do is walk through the results, the report from a previously run test. The execution report, it shows the objective of the test at the top, which is to verify that the data packets sent over the N3 interface are replay protected. And it lists the 3GPP SCAS reference and the test case name. The topology shows the actual resources that have been assigned for this test run. There's a statistics section that shows various statistics, including the start and end time and the duration of the test, a summary of the different types of messages that were seen. The artifacts, these are links to additional result files from the test. And then the execution messages show a step-by-step guide of what happened during the test. When the test started, you can see that the parameter values are applied. Then the actual test script starts to run with those applied parameter values. When the test script execution completes, we analyze the results. Now, each test has a defined set of KPIs. And here you can see that we are comparing the actual values against the expected values. The test also will measure the SUT's CPU and memory utilization and compare the actual values to predefined thresholds. So these acceptance criteria are marked as pass. There's one additional analysis step, which is to inspect the PCAP file that was captured during the test run. And this is to make sure that the UPF did in fact ignore any of the replayed packets. So if we look at the packet with sequence 9, the first packet was sent and a response was received. The second packet, so this is the duplicated packet, it was duplicated immediately and no response was received. And then looking at the packet with sequence number 11, the packet was sent and a response received. And then the replay packet was sent out after a 10-second delay. And the analysis shows that no response was received, and that's the expected behavior. So I scroll down to the end and you can see that the overall result of the test is a pass, and it reports the execution time of 3 minutes and 26 seconds. Now, if I look at the PCAP file from this test run, you can see the messages being exchanged between the G-Node B and the 5G core. So we've got the registration request, we've got PDU session establishment, we've got the secure data connection being set up, and then finally we've got the encapsulated payload being sent between the G-Node B and the UPF. So I'm going to look at the packets that have a sequence number of 9. And here you can see the packet being sent from the G-Node B to the UPF, and a response is received. And then in packet 80, this is our replayed packet. It's been sent again from the G-Node B to the UPF, but there is no response received. And for sequence number 11, again, you see a packet being sent from the G-Node B to the UPF and a response received from the UPF. And then 10 seconds later, the packet is replayed again, but no response is received from the UPF, which is the expected behavior. This demo showed how the Spirent security solution can emulate a user plane replay attack towards the UPF and verify that the UPF drops any replayed packets. The test was run using the Security Automation Test Pack. It was run from the GUI, but it can also be run via an external API and can easily be included in a CI/CD environment.